Greetings and welcome. Subscribe the channel Thermal Engineering for video sessions. In this session, you will be able to explain the concept of fluid mechanics as the properties of fluid: mass density, weight density, specific volume and specific gravity. As far as properties of fluid are concerned, there are two types of physical properties: intensive properties and extensive properties. Intensive properties are independent of the mass of a system. For example, boiling point, temperature, melting point. These properties are not dependent on the mass of a system. Extensive properties are the properties which are depending on the mass of a system, means these are changing with change in mass. For example, size, volume, weight, energy. In this video session, we are especially going to discuss about the main four properties of the fluid: mass density, weight density, specific volume and specific gravity. As we know, mass is amount of matter. Here we see in this image, these are the fruits which are placed on this mass balance. So here its mass is 1 kg, 1 kilogram. So it indicates that mass, that is amount of matter. Volume is a property. This is a space occupied by the substance. Here we see two pebbles which are immersed in a liquid. This is large one in a size and this small in a size. Here when it is deep in this liquid, then here, due to space occupied by this large pebble, here there is a rise of liquid which is shown here with this dotted line. So here it indicates that this is the volume about 30 cubic centimeter for the first case. Similarly, here in case of small pebble, this space occupied by it, that is volume, that is shown here as a 10 cubic centimeter. Now if we take ratio of mass to the volume, then it is called as mass density. It is mathematically indicated by the Greek symbol rho, mass upon volume, and if you see unit, then mass we measure in kilogram, volume in meter cube. So density unit is kilogram per meter cube. As an example, density of oil is 800 kg per meter cube, and density of water, that is standard value, is taken 1000 kilogram per meter cube. Here from these two photographs, we see that for same substance the density is same. So here these are three different beakers. In that same liquid is filled and ratio of mass to its volume in respective beaker is shown here. But if you see here, the ratio is same for all, that is what density. On the right side here, for the solid object having different sizes, here also with the values it is indicated that here this ratio is same, that is density of this object is same for all the different masses and volumes. So mass density is especially used in a fluid mechanics subject for the different studies of fluid. Here we see in this glass different liquids are filled. So these are, from this we see that honey is a having highest density, means it is more denser fluid or liquid, that's why it is deposited at the bottom. Above it corn syrup, dish soap, water, and at the top vegetable oil, means it is a light most fluid, means its density is low as compared to honey, so that's why it is deposited at the top. Here we see that these are the two cubical shaped blocks of same volume, but here on the right side the mass quantity is higher, so mass to the volume, the ratio is higher, that's why right side cube is having high density. The next property is weight density. It is the ratio of weight per unit volume. Mathematically it is indicated by Greek symbol gamma, as W, capital W, is equal to m into g. M is a mass and g is the acceleration due to gravity. Here weight is measured in Newton and volume is measured in meter cube, so unit of weight density is Newton per meter cube. Further, this mg upon v, in that m upon v is a ratio, that is a density, means rho, so weight density gamma is equal to rho into g. Weight density is also called as specific weight. Specific volume, this is the term which is the ratio of volume per unit mass. It is indicated by letter small v. Mathematically it is written as capital V by m. Now as m by v is a rho, so v by m will be 1 upon rho. So it is reciprocal of density, means specific volume is reciprocal of mass density. As far as unit is concerned, meter cube per kg is the unit of specific volume, means number of cubic meters occupied by 1 kilogram of a particular substance is called as specific volume. Here the specific volume is term we can understand. Mostly this term is used in thermodynamic applications. Here we see this is a ideal gas law, for that this is a figure or image which is used. Here we see this is the gas which is containing in this gas container or piston, you say. This piston when is lowered, then this gas is getting compressed, means its volume is decreased. So when the volume is decreased, then obviously its pressure is increased. Now here if you see, for the same mass, when the volume is decreasing, then volume upon mass ratio is decreasing, means in case of compression or in case of increase of pressure, here specific volume of the gas is, we say, decreasing. The second concept or second example here, in case of when the heat is given to the gas which is contained in this closed container, so here by the application of heat or addition of heat to this gas molecule, these are getting expanded, so its volume is increasing. So for the same mass, if you say about ratio, then increased volume to the mass ratio means here is increase in specific volume with increase in temperature of a gas. So these two things which are happening in case of gas. Specific gravity, it is also called as relative density because it is dimensionless quantity, as it is ratio of density of a substance, means any substance, to the density of some standard substance. at a specified temperature of 4 degrees Celsius. Means specific gravity measurement is carried out with recommended temperature value of 4 degrees Celsius. Mathematically it is indicated by letter SG, and that is equal to rho F by rho W. Rho F is density of fluid and rho W is density of water. Now here this is what comparison between the two density. Now in this case, for a liquid, means to finding the specific gravity of liquid, standard substance is considered as a water, and to find specific gravity of gas, standard substance is considered as a air. To find or to measure specific gravity, the instrument which is used, that is called as hydrometer. Here we see this is a scale which is provided here on this hydrometer for the different kinds of water to give the values of specific gravity. Importance of specific gravity is here shown by this graph. Here, to check the quality of water, that is distilled water which is used in a battery. So to check the quality of battery water, specific gravity term is used. Here we see two specific gravity values. When the battery is charged at 80%, its specific gravity is about 1.13, and for the 100% charged battery, the specific gravity value is about 1.27. Means here, when the specific gravity is in the range of 1.13 to 1.27, it is said that it is safe for use. Now, in the case, instead of charging the battery, when the specific gravity is remaining less than 1.13, in that case, that battery should be replaced. Here, use of specific gravity is also done in order to understand whether any object, if we keep in a liquid, whether it will sink or float on the liquid. That will be decided by the ratio that is called as specific gravity. So here we see relative density, means specific gravity ratio. Here the first case in which this is a steel ball, so its density is given 7800 kilogram per meter cube divided by density of water 1000 kg per meter cube. So ratio specific gravity 7.8 comes for the steel, which is higher than 1. So obviously in this case this steel ball is sinking in the water. Second case is of wooden sphere or ball. Its density is 500 kg per meter cube. Its ratio to the density of water, that comes 0.5. So here specific gravity for the wood comes 0.5, that is less than 1. So that's why it is lighter than the water. That's why it is floating on the water. Here in this table, different values of specific gravity for the different materials are mentioned. From this diagram also we can understand that this is a cork and wood. These both are having specific gravity less than 1. That's why these are floating on the water. And this is aluminium ball. Its specific gravity is greater than 1. That's why it is sinking in water. So at the end of this session you can explain mass density, weight density, specific volume and specific gravity. Subscribe the channel for further video sessions of fluid mechanics. Thank you.